Here's the second page for factoring. Here we're looking at an x to the fourth. In a previous problem, we treated this just like a quadratic, but now you look at that middle term and you see a 3. That's not half. And in fact, you see a c in every one of these. You even see a multiple of 4. So I have a GCF of 4c squared. That's going to leave us a c squared minus 4c plus 4. Now we have actually a quadratic that we can factor apart. And we're going to get c times c, that multiplies to be c squared. 2 times 2, that multiplies to be 4. And when you do the outer and inner, if you had a negative 2 and a negative 2, that would add to be negative 4, but still multiply to be positive 4. Here we have a leading coefficient of 1. So when you have a leading coefficient of 1, it's a lot easier. You think of what times what makes x squared. Of course, those are going to be x's. Now there's multiple ways for us to get up to 40. Okay, 20 times 2, obviously 40 times 1, 5 times 8, 10 times 4. But we're trying to figure out which one of those are 6 apart from each other. So the 10 and the 4, if it's a positive 10 and a negative 4, those would add together to be a positive 6. So here's one which has a GCF of 4, because we can divide 4 into all of those, and they all have at least a y squared. So we have a GCF of 4y squared. That's going to leave us y to the fourth minus 5y squared plus 6. Now this is that fourth power one, but notice how we're second power for the middle term. So we're able to treat this just like a quadratic, because x squared and x squared multiply together to be x to the fourth. Here you got to be careful. You want to use 6 and 1, because 6 and 1 make 6 and add to be 5. But the signs have to be the same, so it actually has to be 2 and 3. That's the only way to multiply to be 6 and add to be negative 5. These are not difference of two cubes or squares, so we cannot factor that any further. Here's one. If we use guess and check, we know we're going to use 3x and x. What multiplies to be 20 would have to be here, like 5 and 4, or 2 and 10, or 20 and 1. So if we use 2 and 10, that would be 10 out here would be 30. I can't get to 7 using a 30. So let's try 10 and 2. That would be 6 and 10. That still seems too big. 5 and 4, 4 and 5. 4 would be 12. 3 and 4 would be 12. And a 5, that would be 12 and 5. Positive 12 and a negative 5, that makes 7. So that is the exact example of guess and check. It's tricky for some. Some would prefer to use a calculation method to work through it. And that's when we've used factor by grouping. Here we have the difference of two items that are perfect squares. That means we can take the square root. That's 81, and yes, that equals 9. So we're going to have 2x minus 9 and 2x plus 9. When you multiply the front, you get 2 times 2 and x times x. That's 4x squared. A positive 18 and a negative 18. That makes 0 in the middle. And then 9 and 9 is 81. here. Now this one's a great one to guess and check on because both numbers, the first and the third number, are prime numbers. So we know the first number is going to be 2x in x, because that's how you multiply to be 2x squared. We know the last numbers are going to be 3 and 1. We just don't know if the 3 goes with the 3 or if the 3 goes with, if we don't know if the 3 goes with the 2, 3 and 1, or is it 1 and 3? Well, let's try it. If this was the 2, actually the 1, that would be 2 times 1 and 3. That could almost work. But your signs would have to be the same. 2 and then 3. 2 times 1 is 2, and 3 times 1, that adds to be 5. But the signs would have to be the same. That multiplies to be a negative. So I believe this is going to have to be 6 and 1. A negative 6 and a positive 1. That gives us a negative 3 when we multiply, and that gives us a negative 5 when we add them. Here's the difference of two cubes again. We know our rule for the difference of two cubes. We do our cube root of each term. We square the first term. We change the sign. We multiply the two together, and we square the second term. So I know my cube root. When we take the cubed root of 8a cubed, we get 2a. And when we take the cubed root of 27, we get 3. So we're going to use 2a and use that sign, so a minus 3. 2a and 2a is 4a squared, so we got to square the 2a. Not just 2a squared, but it's got to be 2 times 2 and a times a. Then we multiply the 2 together and change the sign, and then square the 3. Here we have a GCF. We can pull that 3 out. And keep that GCF there. Don't lose that GCF. X times x is x squared. It would have to be 11 and 1. That's the only thing that multiplies to be 11. But it would have to be a negative 11 and a positive 1. That multiplies to be negative 11, but that still adds to be negative 10. We look at our next one here, and we have x to the 4th power. So, again, we don't have any rules for 4th power, but we're going to treat this just like the difference of two squares. So we're going to treat this as x squared and x squared. That multiplies together, and you add your exponents to get x to the 4th. 4 times 4 multiplies together to be 16. And if the signs are different, we have conjugates of each other, and that makes 0 for the middle. Now, what's tricky about this one is that this needs to be factored further. This is the difference of two squares again. So you're looking for your two terms that multiply to be x squared and your two terms that multiply to be 4, and your signs have to be opposites. You cannot factor x squared plus 4. That is not x plus 2, x plus 2. This is the only thing you can do. This has 4 terms to it, so we're going to use factor by grouping to work our way through. We get n squared, n plus 5. Bring down your negative. What goes into 9 and into 45 but 9? So that is n plus 5, because a negative 9 and a positive 5 is a negative 45. Bring down your two terms. Bring down what's inside the square roots have to be exactly the same. So, and I notice now that this is the difference of two squares again. So it's n minus 3 and n plus 3. The order of that doesn't matter. It could be n plus 3 and n minus 3. Order doesn't matter. And the n plus 5. We look here at the next one. This is one with x to the 4th and x squared. But this is a pretty big one. Let's see if we can come up with something. If we do 2x squared and x squared, that is 2x to the 4th. Now I need two numbers that make 45. Well, there's a couple different things that multiply to be 45. 9 and 5 is a common one. So if I use 9 and 5, that would be 10 and 9. 2 times 5 is 10, and then the 9, that makes 19. That didn't work. But what if I use the 9 over here and the 5 right here? That's 18 with the 5. Negative 18 and a positive 5 gives you a negative 13. So that's, again, another example of using guess and check to work through this factoring. Then we notice this is the difference of two squares. So you have to factor it completely. You need to be observant. The last one we're working on is here with the sum of two cubes. We've done the difference a few times so far, but this is the sum. So that means we're going to take the cubed root of both terms. Then we're going to square the first term, just like before. We're going to multiply the two together and change the sign. Then we're going to square the second term. So we're going to take the cubed root of 27m cubed. That's going to give us 3m. And the cubed root of 1 is just 1. So we have 3m, use that sign right there, which is a plus 1. When we square 3m, that is not 3m squared. It's 3m times 3m. 3 and 3 is 9. M and m is m squared. Multiply the two together to get 3m. 3 times 1 is 3. Change the sign and square the 1. This trinomial will never be factorable. You never have to worry about that factoring. There you go. Good luck.